Oh, let me stop sharing so we can see Christian's screen.
Can you see my screen now?
Yeah.
Okay. Yeah. All right. So in this chapter, basically what I did or what I wanted to do is put the two tools together, or basically this and the following chapter is about putting everything in place. So in this case, what I did is to focus on four use cases: web applications, batch jobs, compute cost optimization, and GPU-based workloads. And the reason for that is because I wanted to have kind of like a guided tutorial and basically the demos that I've been using at conferences, but put it in the book format, and so that you can see how Kit and Carpenter work together. And in this case, for specifically for web application and batch jobs, we address them in the KEDA chapters, but we stopped at some point adding more capacity. So in this case, the plan is how you can see uh, how everything is interconnected when KEDA is scaling the pods. And when there's no capacity, you can see how Carpenter reacts and add the capacity to it. So it's basically very hands-on, very practical. And I added a kind of like a few diagrams here. Um, and as you can see, as we progress on the use cases, we are adding more complexity into it. Um, and for this one, for the first one specifically, web applications, what I wanted to do here is like um, showcase that it's not only about CPU or memory scaling policies, but it's also in this case, I think I use request per second. Yeah, throughput. Yeah, I use the throughput instead of um, CPU and memory, just so that we can see how it works and
And
how,
this is
how
not
it scales.
using a Prometheus adapter. This is using KEDA, right? KEDA is the one s- talking to Prometheus.
Exactly, exactly, exactly.
And the slash metrics is just normal Prometheus grabbing the metrics of the workloads.
Exactly. So the application was instrumented in a way that the slash metrics expose metrics in the Prometheus format. So that way I can do things like this. So I can use the metrics exposed by the application, how many requests it's getting, and I run some query to kind of like get the throughput or yeah, the requests per second or per 2 minutes in this case. And I said like, and I'm saying like, as soon as you get 25 concurrent requests, um, if you start getting more, start scaling out because you need more capacity. And if you start getting less than this, you can scale down up until you meet this target or this threshold, basically.
So I have a question for Jan. I have a use case around this, being me selfish, right? Using the experts in the room. Um, working with cloud managed agents. Those are like hosted managed agents that can use an environment sandbox, and I'm using that in Kubernetes. This is what I was doing the sandbox. But there's a worm pool that you can configure to say how many pods to have like ready to go, because these agents need to like start like less than a second. But if there's no sessions coming in, right? People are sleeping, people are not running. I want that worm pool to be smaller, but when there's work and there's a tool stats that will give me like how many sessions are coming or in the queue from cloud has the CLI type of thing, and I have the stats, but I think GK had an implementation that it goes directly to the one pool and it updates a number based on like whatever. But I don't want to do it uh, like that. I want to do it with a scale object, or how many pods should go up. And Wormpool has a slash scale API. Do you work with any object that has slash scale API, or it needs to be an HPA?
Yeah, it can be anything, as long as it implements the entire slash scale API. Not only like has a scaling set the status, but it also has to have a replicate or something representing scale in the spec. So essentially, the entire slash scale has to.
But it's one API, it's the slash scale.
Yeah.
Yeah,
It's
it's
it's one API consisting of two things: status and then the desired.
oh, okay. So slash scale has two APIs within it. Okay, perfect.
Yeah. Essentially, it has like two goals. You set how much you want, and you get how much there is. And if it matches, then it's happy. If it doesn't match, then it tries to do something to the desired count.
And I don't have to write a scalar. I can just use
Yeah.
one of the scalars that come with KEDA.
Exactly. As long as you can get the metric from somewhere, then you have a scalar. And as long as it is a CRD that implements the scale sub-resource, you can put it in the target reference.
Okay, I'll look into it. Yeah, this is you presented the typical web application, but it could be anything. That's I
Yeah.
wanted to highlight. Yeah.
Yeah, exactly. I just wanted to show this. I think that the easiest way to test this was using a web application because I can do things like this. I'm running a load test here, um, and I'm being a little bit more aggressive into how we're sending the load test compared to the previous labs that we did. And I guess that it was just, I didn't want to complicate things. Because again, as I was saying before, the idea is to add complexity as we progress and not start with something like super sophisticated, even if it's closer to production, because this is kind of like a learning exercise. I wanted people to
Yeah.
feel confident on this. So yeah, that's basically the first one. And the second one is about using batch jobs and that you can to showcase that you can use as well other CRDs. It's not going to be just deployments, but you can also scale out jobs. In this case, I think I have it here. What I do is the typical, right? That you send, you have a producer and a consumer, and I trigger the producer here that is going to be filling up the queue with messages. And then I'm gonna deploy the scaler, Karpenter in this case. What I have is very specific about I'm being very specific. I wanted to showcase here that being specific about the needs that the pods are gonna have. Like for example, I need to use on-demand instances because if it's gonna be in this case a job that it's too costly to get interrupted, I don't want to the node to be removed because there's a spot interruption. So in this case, what I wanted to show is that you can keep working with the default node pool with as open as or as flexible as possible, and it's your workload, the one that who's going to be setting up the constraints that they need. Like for example, on-demand instances, or if they want to be spread within different availability zones. You can use this here, the topology spread constraints. Basically, everything that we've been learning in the previous chapters, I wanted
Yep.
to put it in practice here.
And we discussed that using Spot requires more effort in terms of the workload to be like,
Yeah.
if it's interrupted and it comes back, where it picks up. But in this case, the example of the queue is like on a task, right? Every
Yes.
message is a task, and you want to finish that task. You don't want it to. It becomes more complicated. The resume, and we discussed that in one of the sessions. So on demand makes sense.
Yes, exactly. And I think that another thing that I do here, I don't have, I think, yeah,
But
this
okay,
one, this
this
one.
is not using a HPA for the jobs.
No, it's using KEDA. It's using KEDA, which it's going to be creating an HPA object.
Okay.
Yeah. Another important thing here that I wanted to highlight is on the Carpenter blueprints, I have this pattern, but in this case, in the book, I went and explained this in more depth, that you can have an annotation here to say do not disrupt. So that way, when even in when you receive a consolidation, as we review as we explore in the previous chapters, that you have voluntary disruptions like drift and consolidation. Even if that comes in, and I actually force that disruption, you can see here that it's gonna be blocked because there's
Okay.
this annotation in the pod. And in this example, what I do is that I deploy two jobs at the same time, one without the annotation and one with the annotation. Saying like, for example, the one without the annotation is gonna be finishing earlier than the other one, and that will kick in consolidation because it's gonna say, hey, there's no the pod that is running here is not running anymore. So the existing node that I have is over provision for the pod that I am running. But this is my way of saying, hey, I know that,
Yeah.
but let the pod run because I need the pod to finish.
I have a reason to keep it running, even if
Yes.
it's the node is underutilized, right?
Yes, yes. So that's of course during the book I go in more depth and explain this easily and in more depth. But that's basically what I wanted to show here. Then on the third use case, this is basically what I been using as a first that as if it was the first time that people was hearing about Karpenter and KEDA, and we actually did this with Jan in a few sessions at the conferences. He was showing kind of like how to scale out the workload, and at some point it was going to be constrained, of course, and it's not going to be optimized. And little by little, with Carpenter, I was kind of like applying certain things into the node pool to decrease the cost. So this specific lab, what I do is that, okay, we're gonna install some tools here to get an estimation of how much is gonna cost the cluster when launching the pods without any optimization. In this case, I have 30 pods running here, and it's gonna cost me this amount a month because of this, right? So you can see
Yeah.
here that there's what we're gonna be doing is um, decreasing the cost of the cluster with some optimization in place. The first thing that I do here in this case, I extend the architecture to include ARM-based architectures. Like for example, in AWS case, it's gonna be Graviton. And what I'm doing here is just I'm extending the list of instance types that Carpenter can use so that it's gonna always optimize for cost, and it's gonna we're basically open the choices that Carpenter is gonna have to launch the cheapest instance type if it's on demand. So that I think, and then I think I show that. Yeah, I don't show this right
And the
here.
ARM makes also is part of the cost optimization, right? The ARM64.
Yeah, yeah.
Um, the thing with ARM64, folks should start like building their applications, right, for ARM64 if they're not, but sometimes they have like images that are like very old and legacy, and they have AMD64. But if there's an opportunity for ARM64, does Carpenter prefers that or not for the architecture?
It's not that. So the way that it works is that if you have both architectures, you basically open the possibility to having more instance types. So you
Yeah.
will have similar instance types both for x86 and ARM64 in the sense of same CPU, same memory. So Carpenter will consider those families as well, and it's gonna pick the cheapest one. It might be that, for example, depending on your constraints, the generation that you might want to use, that at some point, I don't know, x86, it's gonna be cheaper because of your constraints or because there's no capacity. It can fall back or it can use the other instance types. But effectively in AWS, what it does is that just it sends a list and it gives the responsibility to the API, to the cloud provider, to decide which instance type from that list is going to be the cheapest one. That's basically it.
And
Just basically open the options.
there's a one thing that people don't realize, that there's a annotation, right, that you can put in the pod, not in
Yeah,
the pod, right, not in the container. Well, in the pod, annotation in the pod that says
yeah,
the architecture is ARM64, and that's something that Karpenter reads, right?
yes, yes. You can either if you don't put it, Carpenter is gonna use both. And if the workload has it could be a node selector, it could be an affinity um, specifically to this using this label and any of these values. And that Carpenter will use that constraint.
Yeah, so it's important if it's ARM64 to put the ARM64 on the pod, right? That's something we were talking about, like evaluation of an agent. Like an agent can tell you like
Put both.
the only reason that this is not being optimized is because you forgot to put this annotation in your pod, right? That you should be driven from a Helm chart or customized and things like that.
Yeah. Yeah, exactly. And the next thing that I really like to show is like imagine that you've been working on your application and you've been profiling this, and all of a sudden you notice that you were over provisioning on the CPU and memory. And instead of requesting one CPU, you actually needed 1/4 of the CPU. And instead of requesting this type amount of memory, you only needed half of it. And in this case, what I'm showing or what I want you to see is that by just changing this request into the pod and not changing anything else, Carpenter consolidation will kick in and will replace the nodes with smaller ones, therefore decreasing the cost. So we've been looking at kind of like already at techniques at being as diversified as possible because Carpenter will choose the best one, and then being more intentional on the resources that your workloads are gonna request, so that Carpenter only provisions what it needs.
And there's like this is something easy to detect, right? If you have observability, that's why it's important to have observability. And I think some of the kubestat metrics and a bunch of like Kubernetes dashboards already have this um, request versus use, right?
Yeah,
That you can always see that, and going back to the AI agents, right? You can say, for the last month,
yeah,
find what is if there's any difference, or what is the difference between the usage of memory and CPU versus what these workloads are requesting.
yeah,
And it could be an automated system, right? Doesn't have to be agentic or anything. Like it could be something that you're not familiar these days, right? As necessary practice, you can say, write me a routine that runs every week, right? That goes over the usage versus the request, and then adjust the values, right? And open the PR, and then have GitHubs, and then it goes
yeah,
back, and it's a life cycle, that because that's something that it's a problem for platform teams. When platform teams don't create the app, I would say like it's a fault on both teams. Like the platform team say, well, I didn't create the app. The development team needs to tell me like what are the values to plug here, CPU and memory. And the
hmm,
development team says, well, I create the app, but I don't run it in production. I run it in my laptop, right? So how can I give you the correct
yeah,
value? Or it could be in one region, uh, this needs to be higher, and another region not, but not necessarily, right? The application it uses HPAs, right? That you have a horizontal, so you try to minimize the request on every pod, and then scale by having more pods, right? So that's always like the guidance principle on that. And it's a matter of like observability. You don't have observability, you don't know if you're wasting.
Yeah,
And you put
exactly.
here, I read a number, right? 70, where it says 75%, somewhere I saw. Um,
17% of its resources allocated.
at the bottom, it says, what's
Ah, yeah.
$106 giving us 75 cost reduction,
Yeah.
right? That's like, I should, if I'm the admin, I should get a raise,
Exactly. Yeah, yeah.
right?
Yeah.
By proving these type of things, right? That these things were not optimized, and you can show like how much waste, right, in the last 6 months we could save,
Yeah. John
right? Like,
John used to say in the conferences that based on how much we saved, the rest is gonna be the allowance for
Beer. Yeah.
for beer or for the kids to spend.
or new projects, right?
Yeah.
Like, if you are a platform engineer, and you want to spend time on your team to look into these new agentic projects or AI ops, and the team says, well, we're already like buried on like maintaining the systems. We cannot hire, we cannot like this is something that you can get cost, right?
Yes.
Or the usage of the models, right? We cannot pay for the API cost of the tokens. Well, here's how we pay for the tokens.
Yes, exactly. Actually, Intercom, a UK customer, said that I had a session with them and they actually recorded a testimonial last year saying that, yeah, the savings that they got by doing all of these optimizations, not with Carpenter specifically, but optimizing how much their compute usage was, it allows them to reinvest that money into their AI strategy.
Yeah,
So yeah.
exactly. Yep.
And yeah, I mean the last leverage is basically pulling out the other instance type or capacity type around spot. And once you have all that in combination, I think that I don't yeah, I included the math here and you kept reducing to even 53% cost reduction just by changing the capacity type to spot. Saying, of course, that your application needs to be spot friendly, as we said before, right? Fault tolerant, perhaps is the main factor, and that it can recover in less than 2 minutes in this case.
But this is a low no percentage. I mean, we have customers, at least from my cloud, that's way more than 53% at scale. That the massive projects that they bet, right? Because some of these businesses are SaaS, so
Mhm.
their margin needs to be like a very they pinpoint that margin, and they get a lot of guidance, right? They look for a lot of guidance on how to use Spot, taking care of the resume, using S3, using databases, using open source projects, like Unicorn, all this batch processing, right? Batch processing uses a lot of Spot.
Mhm.
Q, which is the other project. There's a lot of projects that capitalize on Spot because it's like
Yeah.
small pieces of work that can be interrupted and anytime, and it continues on the next one will pick up. Um, and it's extra capacity is available depending on the region, right? You have to check on the region if there's extra capacity for the instance types that you have. But again, making that larger instance type, but making them job, you have a high chance of getting a instance for it.
Yeah, and more than the size or the region, it's basically about allowing Carpenter to diversify as much as possible, and you
Yeah.
let its own by its own to pick the cheapest one, and that's it. And there's at the time of the writing this book, I think now it's gonna be 1.5 years now. Oh my God, time flies. At that point in time, Carpenter recently released the support for reserved capacity and on-demand capacity reservations in the case of AWS. But effectively, what this means is that there might be customers or use cases where you have reserved capacity and it's something that you already paying for it. So you want Carpenter to prioritize that because effectively what it means is going to be like free capacity, so to speak, because you already pay for it and you just want to use it. And at that point in time, Carpenter included the possibility of using spot on demand and reserved. And of course, what I say here in this note that reserved because is technically free capacity is gonna be prioritized, and then it's gonna go on spot, and then it's gonna go on demand. Um, I didn't have. I was already running at what 322 pages, and I didn't want to keep adding more and more patterns because I don't think this is gonna be the place for it. On the Carpenter blueprints, we released a blueprint that goes in depth and talks about this as well. So if you want to check it out and see the latest, it's there in the blueprints.
But it's still, I remember that Carpenter didn't have this when it launched, right? So that was a friction for people to use it because they wanted to tell Carpenter like influencer like pick from the instance size that already reserved, right? Already paid for. Do not pick any random on demand because
Yeah.
then that would be more costly. Like that was the contract that they went in, and it's influencing that. Is that something that is can be done in one node pool, or that's something that you have to do in two node pools with a weight?
Exactly. The pattern, as you mentioned, before this, it was to have two no pools, and one is was going to have specifically to what you reserved, and limiting the capacity of that no pool so that when that limit is reached, then Carpenter will discard that no pool and go with the next one, and effectively kind of like going with spot or on demand. But with this, you reduce the complexity by just adding that other model and automatically prioritize that. Of course, there's something in the node class that you have to specify the tags that you use to purchase that capacity so that Carpenter can match that. Otherwise, it's still not going to work. But again, the devil is in the details, and those details are specified in that blueprint. So give it a go if you're curious about it as well.
Or a specific tag in the class, but still one node pool, not this. I remember not
Yeah,
to
one
have
no
two
pool,
node
one no
pools when
pool.
the weight.
Yeah, one no pool, one no pool.
Okay, okay.
Yeah,
Because for I don't know if you talk about weights in the book, but weights is something also that people
yeah,
should be aware that you can have multiple node pools that can satisfy a pending pod, but maybe you want to prefer this type of node pool onto certain point and then this other one. Or it could be like at this time, I cannot satisfy the pod with this node pool that has higher weight. It's just one field, right? It's weight. So
yes,
you can
wait,
pay, you
it's
can
wait.
put like, I don't know, 90 and 100 or 90 and 80, just two weights of like, this is better than this one. So try this one first if you can satisfy. And then for whatever reason it cannot satisfy, it was like, well, try the other one, right? Is that correct? How it works?
Yeah, yeah. It basically, effectively, what it means is that you're assigning a priority, so to speak,
Yeah.
when Carpenter finds many node pools as candidates to decide which type of nodes to launch. So with this, is just basically you're given a priority.
Why
It,
did he call it priority? That's an easy word for me to
yeah,
pronounce
I
from the
don't know.
Spanish speaking
I
person.
don't know.
And
Yeah,
other things in Kubernetes, right, has priority, like the pod priority.
yeah, agree.
It's ready to eviction, but it's not eviction. It's like, oh, they use wait. There's a question
Agree.
from Christian. Let me see. How many companies actively use the auto scaling strategy? Sometimes provisioned. Base capacity provides well-known resiliency, aka less chances to impact users. Just companies pay more upfront. The auto scaling versus static, I guess. The with the observation of like well-known resiliency. What do you think these days with auto
So
scaling?
the pattern that I've seen is, and I've been hearing that from many customers, is like initially um, they are not very interested or not pushed to cost optimize. So they say like, hey, I know that auto scaling will reduce the cost, but right now that's not our priority because imagine it could be a startup and the first mission is to get customers So maybe at that point in time, it's not about efficiency, but later on, they need to be optimized for cost. So I think that it's going to be at different stages and how well prepared the applications are to basically interruptions, because autoscaling means that they're gonna get interruptions as well when decreasing the load as well, right? Jack, I think you raised your hand.
So, so I'm from Nokia, and so I'm retired. And before I retired, we had customers who told us we had to configure to allow for the variations in the use of mobile phones during the day.
Hmm.
So we'd always configure for the peak usage of the mobile phone during the day. And so, when people get off work or people going to work, there's more peak, or there's certain periods during the day, and so forth, right? So you engineer for the peak for the day, and then so it gets written into the contracts that way. Then the operations people call us up and say, "How come you're saying you require this many resources when we can see that you're only using 10% of them?" And so we have purchasing people saying one thing and operations people saying another. So there's actually like a little bit of a conflict, and I don't know that it's been resolved. It's a business problem as opposed to a technical problem. On the other hand, when World Cup comes, there's whole things called network slices that get set up, and whole big configurations for around all the World Cup stadiums, where auto scaling gets kicked in for the duration of the game. And so it's a very complicated question, and it's not the technical question; it's a business question.
Yeah,
Yeah.
but sometimes I guess it depends on the profile of the company or the stage where they
Oh
are.
yeah, yeah, yeah.
Sometimes
And it's probably
it's like
changed since I
that.
retired. It's probably
Yeah.
changed since I retired. Yeah.
Yeah, yeah. And other times it's just their applications are not supported or um
Yeah, how you purchase things also, like Jack's saying, like procurement, right? Procurement, sometimes some companies cannot pay as you go, right? Companies, they have to
Oh yeah. It
budget
becomes a capital
what they are going
expense.
to
It's a
spend.
capital
Yeah,
expense, right?
yeah,
It's
capital
a capital
expense.
expense. Yeah.
if I,
Okay, I think
yeah.
we're out of time. I need to jump to another session, but thank you, Christian and Jan. I know it's late. It's almost 7 p.m. for you guys. Hope that you are ready. I know hope I know for sure that you're ready for tomorrow. You have a session that you're going to help folks. I think it's a 1 hour and a half of
Yeah.
like folks getting to this space, learning, having experts like you to answer their questions and concerns and how to get their hands dirty, right? Being
Mhm.
learning this stuff. So I hope that you have a great time and the community enjoys your presence there and the knowledge that they joined. So, and then thank you for the people that joined today. And then I'm going to post this also in YouTube. And
Are we going to have a meeting
uh,
next week?
I think next week, maybe the last one. I don't know. What do you think, Christian?
Yeah. Yeah. Yeah, yeah.
Okay.